Welcome to Himani Coaching Center. We are committed to simplify concepts and amplify confidence of all the students who are watching our videos to learn maths, physics, and chemistry. Students, today we are going to take competency-based questions from CBSE site on triangles. This video is meant for students of class 10th CBSE board. So if you are watching this channel for the first time, please subscribe to the video, subscribe to the channel, press the bell icon. Also request to all of those who are watching it, please like the video, share it with your friends and help us spread word about our YouTube channel. Now let us go to the question. It's a 5 marker and again the questions are about testing the knowledge application. Okay, so if you look here, question is in the figure below, P, Q, and R are collinear. That means they lie on the same line. P and Q are the centers of the two circles. P lies on the circumference of the circle with center Q. R is 10 centimeter from Q and 15 centimeter from P. Both the circles have two common tangents from point R. We are asked to find the radius of the circle P. Okay, we are asked to find radius of the circle P. And we, of course, we have to show all the working and draw the diagram. Now understand, let us first draw whatever is given. So since these points are collinear, let us draw a line. Okay, so this is the line which will be there. We are told that R is 10 centimeter from Q. Now this is Q. So this distance is 10 centimeter. We are also told that 15 centimeter from P is the distance of R. So that means this distance from here to here is 15 centimeter. So students, can we now find radius of circle with center Q? Yes. Why? Because QP is the radius of circle with center Q. Okay. So what would be QP? It would be PR minus QR. So which is 15 minus 10 and we get the radius is equal to 5 centimeters. So this much is 5 centimeter. Okay. So having established that, let us now move to the next part. So once we are done, now since the tangents are given, so the angle between radius and tangent of a circle is how much? 90 degree. Okay, so let us draw tangents from Q, the radius from Q on tangent R. Let us say it meets at A. I'm just writing A. So this angle would be 90 degree. Also, P is this and this is the radius PB. That will also be 90 degree. Correct? Why are we saying 90 degree? Because of the theorem, and since it is a 5 marker, you are supposed to write that down. That angle QAR is equal to angle PBR equal to 90 degree. Angle between radius and tangent of a circle is 90 degree. Okay, so I'll just remove the statement, but this is what you are supposed to write in the exam. Okay, now we are supposed to find the radius of circle P. That means we have to find PB. Now let us rejoin this line RQP. So I join this. Okay. See, I'm drawing it with my stylus on the screen, so the line is not straight, but please draw it straight with the help of a scale. Okay, for the purpose of this discussion, this line PQR is a straight line. Now look at triangle RAQ and triangle RBP. Okay, now angle ARQ is equal to angle BRP. Why? The measure of the angle is same, so that angle is common. Correct? And we just proved this already. So let us bring it down. So, okay, let us keep it there only. So, and let us write angle QAR is equal to angle PBR 90 degree. So, what will happen? Triangle RAQ is similar to triangle RBP by AA theorem. And what happens if the triangles are similar? I think I will have to redraw the diagram. Just give me a second. So I am redrawing it because it changed the drawing. So this is what we are saying, and I have A here and B here. So now once the triangles are similar, what will happen? Corresponding sides of similar triangles are in the same ratio. So if we use that concept, so we can say that QA by PB, which is this side and this side, should be equal to QR by QP. Now, what is QA? QA is radii of circle with center Q. So it should be equal to 5. We just proved QR and QP are given. So let us write that down. So QA, which is 5, by PB, which we need to find, equals QR, which is 10, by QP, which is 50. Okay. So you will find that we can do cross multiplication, and 10 times PB is equal to 15 times 5, which is 75. So PB is 75 by 10 or 7.5 centimeter. So this is how you will be solving the question. Again, if you notice, you are asked a question in which your knowledge of circles is also tested. It's a question from triangles, but we are using properties of circles as well. Okay. Now let us move to next question. Here we are given two chords of a circle, PQ and MN, intersect at point P. Show that PT times TQ equals MT times TN. Draw the figure. Okay, that figure is drawn here. I have copied it because if I draw with my pen, it will not be that good. So now the second part we will see in the next page. Okay, so let us first show this. So again, see, students, you have learned in class ninth that angles in the same segment by a chord or an arc are equal. Okay. Now let us look at triangle TPM and TNQ. Okay. Let us look at triangle TPM and triangle TNQ. This angle and this angle are equal. Why? If you see, both these angles are made by arc MQ. And if you are confused, you can just join MQ. So chord MQ is making angle MPQ, which I can say arc MQ also. Similarly, same chord or arc is making another angle, which is MNQ. So they are angles in the same segment. Okay. So with the same logic, okay, with the same logic, this angle and this angle will also be equal. If you notice, at angle T, vertically opposite angles are also equal. So we have to use any two angles to prove similarity. So let us go ahead and now write that down. So now we will say angle MPT is equal to angle QNT. Also, angle PMT equals angle NQT. And why? The reason is angles in the same segment by arcs are equal. So now just note these points. Okay, I'm just waiting for a few seconds for you to note that down. Then I will erase this. Now once that happens, what will we get? We will get that the triangles are similar by AA. So let us do that now. So we will say therefore triangle TPM is similar to triangle TNQ. So because of that, what will happen? TP by TN would be equal to MT by QT. Okay. Why? In the similar triangles, corresponding sides are in the same ratio. So you have to write that down. Why? Because this is a 5 marker question. You will have to write that down. Now to prove this, we just have to cross multiply. So just cross multiply. So that will give us TP or PT. We can copy what they have asked, and whether you write TP or PT means the same. So PT into TQ is equal to MT times TN. So that is part one of the question. Now we will move to second part, for which diagram is on the next page. So now shown below is a circle with center O. Use the result from part 1 to find length of ZY. Okay, so we have to find this. Again, can you see what is happening? It's the same question. Two chords, they are intersecting. So when they are intersecting, so when they intersect, we just showed that PT into TQ equals MT into TN. So we will simply use that. So we will say XZ into ZY should be equal to AZ into ZB. Now XZ is 8, ZY is to be found, AZ is 10 and ZB is 4. So ZY is 40 by 8, so which is 5 centimeter. Okay. Again, question is from triangles, but your knowledge of circles, which you learned in class 9th, is being tested here. Now let us move to 1 marker questions, which are, let us see. First question is very simple. It says give an example each for when two rectangles are similar. So for similar, what will you do? You will say, okay, let there be a rectangle with sides 4 centimeter and 8 centimeter. Okay. Or maybe, you can make it 6 centimeter. Now the sides are in same ratio. So the second rectangle we will say, let us say this is breadth and this is length. So for the second we will say breadth is 2 and length is 3. So they would be now similar. Okay. For not similar, just ensure that the sides are not in same ratio. So L is 6 centimeter. Now take B as 5 centimeter and keep L as perhaps again 5 centimeter. So now they are not similar. Next question, painted cuboid or solid P. So this is painted, is cut along a plane to get two identical solids. One of the identical solids, solid Q, is shown below. What is the area of the solid cube that is not painted? So if you look at this diagram, see this part, okay, is actually this. What is that? In a rectangle, this is the diagonal, and we will use Pythagoras theorem to find the length of the diagonal. So just write this down, A, B, C, D, perhaps. So if you use Pythagoras theorem, okay, so we have to find area of the not painted part. So this much is 20, we know, yeah, because this is 20. Now we have to find this BD. So let us find that. Once we get that, it's a rectangular shape. BD into 20 would be our answer. Now if you look at triangle ABD, BD square equals 5 square plus 12 square. So BD square equals 25 plus 144, which is 169, and square root of 169 is 13. So we now know that this much is 13 centimeter. So now can we find the area of the unpainted part? Yes, it is simple. 13 times 20, which is 260 centimeter square. Okay. With this, we come to the end of today's video. In the next video, we will take a case study question from triangles, which again is a peculiar kind of question. So, students, I would strongly urge you to watch these videos on competency based questions again and again, three times, four times, and solve these questions yourself. Remember, this is the first year when competency based questions are going to be asked. So, be prepared well for these kind of questions. Thank you.